Selection sort. In this video, the objective is to apply the selection sort algorithm to sort the elements of an array or array list, and compute its statement execution count. So, what do I mean by sort? Well, in a programming context, sort means to arrange data in a predefined sequence. And what I mean by predefined is that the programmer defines what it means to be in order, what it means to be in sequence. You can mean from least to greatest, greatest to least. You could mean alphabetically, and you could also mean chronologically. In this video, we're just going to focus on sorting numbers from least to greatest, but the technique applied here can be applied in any context, regardless of how you define sorting for your application. So, how does selection sort work? Well, first, it starts out by assuming that the value at position 0, index 0, is the smallest value. That's not the final conclusion, that's just our assumption for now. Then we're going to compare it to the value at index 1. We see that that value is smaller, so 1 becomes our minimum index. Next, we compare that value to the value at position 2. That value is larger, so we do nothing. 3 is also larger, so we do nothing. 142 is larger, we do nothing. 53 is larger. 17 is smaller, so now 6 becomes our minimum index. Next, 7 is larger than 17. 8 is smaller, so now 8 becomes our minimum index. 63 is larger, so we do nothing, and that completes the first iteration. And the index that we determined to be our minimum index will swap values with index 0. Also, for analysis purposes, we'll also take note that during that first iteration, we executed 9 comparisons. So, on to the second iteration. Now we assume that index 1 is the minimum value remaining. But that's not our final answer, we're just assuming that for now. Compared to 72, 72 is larger, 100 is larger, 142 is larger, 53 is larger, 17 is smaller, so 6 becomes the new minimum index. 94, larger, larger, and larger. And that completes iteration 2, and now we're going to swap 6 with index 1. And during that iteration, we executed 8 comparisons. Now on to iteration 3. Index 2 we set to be the minimum index. 100 is larger, 142 is larger, 53 is smaller, so 5 becomes the new minimum index. 38 smaller, so 6 becomes the new minimum index. Larger, larger, larger. And that completes iteration 3. So now we swap index 6 with index 2. And during that iteration, we executed 7 comparisons. Next, iteration 4, we assume index 3 is the minimum, 142 is larger, 53 is smaller, so 5 becomes the new minimum index, 72 larger, 94 larger, 85 larger, and 63 larger. And that completes iteration 4. So now we swap index 5 with index 3. And during that iteration, we executed 6 comparisons. Next iteration. Index 4 set as the minimum, 100 smaller, 72 smaller, 94 larger, 85 larger, 63 smaller. So we swap index 9 with index 4. And during that iteration, we performed 5 comparisons. Next iteration, index 5 set to the minimum, 72 is smaller, so index 6 is the new minimum, larger, larger, larger. Okay. So that completes that iteration. We swap index 6 with index 5. And we performed 4 comparisons during that iteration. Next iteration, we assume index 6 is the smallest value, 94 smaller, 85 smaller, 142 larger. So now index 8 is the minimum index. We swap it with index 6. And during that iteration, we performed 3 comparisons. Next, minimum index set to 7, 94 compared to 100, larger, 142 larger. And that completes that iteration. And here, with no swapping necessary, we simply finalize 94 at that position. and we only needed 2 comparisons during that 8th iteration. Iteration 9, we set 8 to the minimum index, compared to 142. 142 is larger, so we do nothing. And once again, no swapping necessary, we simply finalize that position. And only 1 comparison was done during that iteration. And then for the 10th and final iteration, no comparison needed, we simply finalize that value. In summary, the total number of comparisons performed by selection sort will always equal size minus 1 plus size minus 2 plus size minus 3, so on and so forth, all the way down to 1, which will always equal 0.5 times the size squared minus size, where size is simply the number of elements in the array or array list.